Imagine a tranquil morning in the remote Siberian wilderness. The year is 1908. The sun rises over the dense taiga forest, painting the sky with hues of orange and gold. The Evenki people, indigenous reindeer herders, go about their daily routines, unaware that the cosmos is about to unleash its fury. Hundreds of miles away, an invisible force is hurtling towards Earth at an incredible speed. At precisely 7:17 a.m. local time, the silence is shattered. A blinding flash illuminates the sky, followed by a deafening roar. The ground trembles violently, knocking people off their feet. Trees are flattened like matchsticks over an area twice the size of New York City. The Tunguska Event, as it would come to be known, had begun.
The explosion, estimated to be thousands of times more powerful than the atomic bomb dropped on Hiroshima, sent shockwaves rippling around the globe. Seismographs in distant lands registered the seismic disturbances. The blast wave traveled twice around the Earth, leaving scientists baffled and intrigued. In the epicenter of the event, a massive column of fire and smoke rose miles into the atmosphere. Witnesses described a scene of utter devastation. Trees were stripped bare, their trunks charred and pointing away from the blast's epicenter. Animals were incinerated instantly. The air smelled of sulfur and burnt wood. The Tunguska event, though occurring in one of the most sparsely populated regions on Earth, left an indelible mark on our planet and our collective imagination.
While the Tunguska event occurred in a remote area, the stories of those who witnessed the event firsthand provide chilling details. Evenki nomads, traveling miles from the epicenter, recounted the earth shaking so violently that their reindeer were thrown to the ground. They spoke of a fiery ball of light streaking across the sky, followed by a heat so intense that they thought their clothes were on fire.
One man, sitting on his porch facing the direction of the blast, was blown several feet back and briefly lost consciousness. He described the heat as feeling like a second sun had appeared in the sky. These eyewitness accounts, though collected years after the event, paint a vivid picture of the terrifying power unleashed on that fateful morning.
Despite the scale of the explosion, the Tunguska event presented a perplexing mystery: the absence of an impact crater. Scientists expected to find a massive crater at ground zero consistent with the impact of a large meteorite or comet. However, expeditions to the site revealed something unexpected. Instead of a crater, they found a vast area of flattened trees radiating outwards from a central point. The trees at the very center remained standing, though stripped of their branches and bark. This peculiar pattern, resembling a giant butterfly, only deepened the mystery. What could have caused such devastation without leaving a trace of itself?
Section 5. Cosmic suspects, comets, asteroids, and the Tunguska Bolide. The lack of a traditional impact crater led scientists down a rabbit hole of theories. They pondered over various possibilities, each more intriguing than the last. The most widely accepted explanation suggests that the Tunguska event was caused by the airburst of a large meteoroid or a fragment of a comet. This theory has gained traction over the years due to the compelling evidence supporting it. These celestial objects, traveling at tens of thousands of miles per hour, can explode with tremendous force before hitting the ground. The energy released in such an explosion is comparable to that of a nuclear bomb. This airburst theory could explain the absence of a crater and the characteristic pattern of flattened trees. The shockwave from the explosion would have radiated outward, flattening trees in a radial pattern. The intense heat generated by the explosion would have instantly vaporized the object, leaving behind little to no physical evidence on the ground. This vaporization process is key to understanding why no significant fragments were found. But what kind of object was it? This question has puzzled scientists for decades. Was it a rocky meteoroid or an icy comet? Each type of object would have different implications for the nature of the explosion and the resulting damage. Scientists continue to study samples and data to uncover the true nature of the Tunguska Bolide.
Section 6. When Worlds Collide. The Impact Hypothesis. The Tunguska Event, a massive explosion that occurred in 1908 in Siberia, has long fascinated scientists and researchers. Theories abound, but one of the most compelling is the impact hypothesis. Proponents of the impact hypothesis point to the sheer energy released by the Tunguska event, estimated to be equivalent to 15 megatons of TNT. This is a staggering amount of energy, comparable to the most powerful nuclear weapons ever tested. This level of energy is consistent with the impact of a large celestial object, likely a stony meteoroid at least 100 feet in diameter. Such an object, traveling at high velocity, would have had a devastating effect upon entering Earth's atmosphere. As it entered the Earth's atmosphere, this object would have compressed and heated the air in front of it, creating a superheated plasma. The intense heat and pressure would have caused the meteoroid to disintegrate rapidly. This plasma, combined with the shockwave from the object's supersonic passage, would have generated the blinding flash and deafening boom heard by witnesses. Eyewitnesses reported seeing a column of fire and feeling the ground shake, even from miles away. The object itself would have vaporized instantly, explaining the lack of a large impact crater. Instead, the energy was released in the atmosphere, causing widespread devastation over a large area. This airburst scenario remains the most plausible explanation for the Tunguska event, supported by scientific modeling and analysis. Researchers continue to study the event, using modern technology to understand the dynamics of such impacts and their potential effects on Earth.
Section 7, Stranger Than Fiction, Antimatter and Black Holes. While the impact hypothesis remains the leading explanation, the Tunguska event has also fueled more speculative theories. Some have proposed that the explosion was caused by the annihilation of a small amount of antimatter, the elusive counterpart to ordinary matter. When antimatter and matter collide, they annihilate each other in a burst of pure energy. Others have even suggested that a microscopic black hole, a region of space-time with such strong gravity that nothing can escape it, passed through the Earth, creating the Tunguska event. However, these theories lack substantial evidence and are considered highly improbable by most scientists.
Despite over a century of research, the Tunguska event remains an enigma. Scientists have conducted numerous expeditions to the site, collecting soil samples, studying tree rings, and analyzing atmospheric data. They have developed sophisticated computer models to simulate the event and test various hypotheses. Yet many questions remain unanswered. The exact nature of the object that caused the explosion is still debated. The precise trajectory and altitude of the airburst are uncertain. The lack of definitive physical evidence, such as meteorites, continues to fuel speculation and intrigue.
The Tunguska event served as a wake-up call to the potential threat posed by near-Earth objects, or NEOs, like asteroids and comets. It highlighted our planet's vulnerability to cosmic impacts and the importance of developing systems to detect, track, and potentially deflect these celestial threats. In the decades since Tunguska, space agencies around the world have established planetary defense programs. These programs utilize advanced telescopes and radar systems to scan the skies for potentially hazardous NEOs. Scientists are also developing techniques to deflect or disrupt the trajectory of an object on a collision course with Earth. Section 10. Lessons from Tunguska, our cosmic vulnerability. The Tunguska event stands as a stark reminder of our planet's place in a vast and often chaotic cosmos. It underscores the fact that Earth is not immune to cosmic impacts and that even relatively small objects can have devastating consequences. The event highlights the importance of continued scientific research and technological innovation to mitigate these risks. The Tunguska event should serve as a catalyst for global cooperation and a shared commitment to protecting our planet from future cosmic threats. By studying past events like Tunguska, we can better prepare for the future and ensure the long-term survival of humanity. Section 11. The enduring allure of the unknown. Despite the scientific progress made in understanding the Tunguska event, it retains a powerful hold on our collective imagination. The event's mysterious nature, coupled with the remoteness of its location, has made it fertile ground for speculation, folklore, and even conspiracy theories. The Tunguska event has been the subject of countless books, documentaries, and fictional accounts. It has inspired artists, musicians, and writers who have found in it a source of both wonder and terror. The event's enduring allure lies in its ability to remind us of the vastness of the unknown and the limits of our current understanding. Section 12. Could it happen again? Assessing the risk. The Tunguska event, while a singular event in recorded history, raises the question, could it happen again? The answer, unfortunately, is yes. Earth is constantly bombarded by small particles of space dust and debris. Larger objects, like the one that caused the Tunguska event, are much rarer but still pose a real threat. Scientists estimate that an event of Tunguska's magnitude occurs, on average, once every few centuries. While the probability of a specific location being hit is extremely low, the global consequences of such an impact could be catastrophic. This is why planetary defense is crucial. By investing in early detection and deflection technologies, we can reduce the risk posed by these celestial threats. Section 13, Tunguska, a stark reminder from the cosmos. The Tunguska event, a century after it shook the Siberian wilderness, continues to resonate with us. On June 30th, 1908, an explosion flattened over 2,000 square kilometers of forest, leaving a lasting mark on the landscape and our collective memory. It serves as a reminder of our planet's fragility, our cosmic connections, and the importance of scientific inquiry. The event underscores how interconnected we are with the universe and how events in the cosmos can have profound impacts on Earth. While the mystery surrounding the event may never be fully solved, it has inspired generations of scientists, artists, and dreamers alike. Theories abound, from a comet or asteroid impact to more exotic explanations, each sparking curiosity and debate. The Tunguska event is a story that transcends time and place. It connects us to a moment in history that continues to influence our understanding of natural phenomena and our place in the universe. It is a story about the power of nature, the limits of human understanding, and the importance of safeguarding our planet for future generations. The event reminds us of the need for preparedness and the value of scientific research in predicting and mitigating such occurrences. It is a story that reminds us to look up at the stars with both awe and vigilance, knowing that the cosmos holds both beauty and potential danger. As we explore the universe, we must remain aware of the risks and continue to seek knowledge to protect our world.